All right, so for Pythagorean theorem, we're just going to look at some examples here, and we're going to solve them just to show you kind of like what the questions look like and how you go about answering them. And I'm going to show you some misconceptions, the number one thing that kids do wrong, if you will. Let's look at these. Okay. Geometric application of exponents. This is the Pythagorean theorem. This is a very typical question. We're going to look at the second one. Okay, let's do this one first, and then we will get to the one to the left of it. Okay, this is a very standard Pythagorean theorem question. I just showed you the other one, which was a 3, 4, 5 in the last video. I showed you which was what is known as a 3, 4, 5 right triangle, or what we call a Pythagorean triple. Guys, this title, it seems harder than it is. Okay, y'all are gonna come to figure out exactly. Y'all are gonna do a lot of examples with this. You're gonna come to find out it's not nearly as hard as it seems. Okay, I understand y'all are going Pythagorean who? Just bear with it. You're going to know exactly what this is about later. Okay. We're going to look at this second question right here. We're going to look at this one right here. I titled question number 1. So the very first thing you do, your step 1, is you're going to write down the formula. All right, which is a squared plus b squared equals c squared. You're going to do that every single time. Don't try to skip steps. I'm telling you how to do this thing. Write the formula down. Step 2 is you're going to plug in the numbers starting with the hypotenuse. So that would be step 2. Well, the hypotenuse we already looked at is the 3 ways. It's the c value. It is, well, we don't know which one the c value is here. So the way you identify the hypotenuse is it's the longest side, or it's the side across from the right angle. So it's this side over here. It's what we're solving for in this question. All right, you're not always going to be solving for the hypotenuse, but you are in this question. So we're solving for the c value here. All right, so we're going to plug in the other numbers. It does not matter if you put 2 in for a or 5 in for a. What does matter is you get 2 squared plus 5 squared, or 5 squared plus 2 squared. That doesn't matter, because when you're adding it, your order of operations, it doesn't matter if you're adding. It doesn't matter the order of those numbers for this question. All right, so I'm just going to put a 2 squared. I'm putting a 2 in for a, so I'm going to do 2 squared, and then I'm going to put a 5 in for b. I'm going to do 2 squared plus 5 squared. That gives me 4 plus 25. And use your calculators on this, okay? That's what they're there for. 4 squared plus 25 squared equals c squared. So now what kids want to do is they want to add those numbers up, and they want to put it on the right-hand side, and then you get 29, and you're like, oh, okay, well, there's my answer. This is not how you do this, all right? Your answer is not 29. How could that be, excuse me, how can this be 2 inches, that's 5 inches, and that's 29 inches? That doesn't make any sense, all right? So this is not what you're going to do. No, you're going to leave c squared on the right-hand side, and you're going to add the numbers, and you're going to leave them on the left-hand side. 29 equals c squared. Now, remember back to our last unit, how you get the c by itself here. C is not by itself, it's being squared. The inverse, or the opposite of squaring a number, is you take the square root. So when you take the square root of c squared, you're left with c, and that's what we want. We want the c to be all by itself. But if you take the square root of the right-hand side, you're going to take the square root of the left-hand side. And the square root of 29, rounded to the nearest tenth. Remember, yeah, we're using that, what we just did. Square root of 29 is in between the perfect squares. I think 36 would be here. I think this would be 25. You are 4 square roots away from 25, and you're 7 square roots away from 36. So you're a little bit closer to 5 than you are to 6. If you have 7 people in front of you, 4 people behind you, you're about the middle. You're kind of back-ish. I'd say your answer here would be about 5 points, I don't know, 3. Let's check it with a calculator here. Square root of 29. 5.38. So we were pretty close. 5.38 would be your answer. So I'm just going to say it's 5.3. If you want to say 5.4, that's a good answer as well. Okay? So you're going to have to round it to the nearest tenth when you're done. Okay? Feel free to push pause, rewind, figure it out somehow, but that's your first example. All right? Now, the second example is different in the sense that we are not solving for the C value, because the C value is given to us here. So this one's going to look a little bit different. We're going to answer it the same way we always do. A squared plus B squared equals C squared. That's the very first step you always are going to do. You're going to now plug in the values starting with C. The reason why we always want to start with C is if you did 12 squared plus 15 squared equals C squared, you're going to get this whole question wrong, because the C value has got to be the longest side. You're going to put 15 in for C, because the C value is going to be the longest side. Don't get caught up with the title of these points right here. All right, that just happens. Those points are titled A, B, and C. The longest side is going to be 15. You're going to put 12 in for A. You're going to leave B the way it is. Or you could have written A squared plus 12 squared equals 15 squared. The order of A and B doesn't matter, but what does matter is the C value. It's got to be the longest side. I'm going to say that again. You have to put the longest side in for C. 12 squared is going to give you 144. You're going to add that to B squared. And, sorry. That's going to give us 225. See how we're setting this up? Now, to get that B by itself, you do the boxes here. You know, I'm going to get... let's do it like this. It's got to be a little bit longer. Okay. Okay, now on the right hand side, I'm going to put the integers. I'll get 225 minus 144. On the left hand side, I'm going to leave B squared. We want to keep everything positive here because we're not going to get a negative answer. So don't put the variables on the right and get the integers on the left. You get negatives there, and then you get the same thing. It's just a little bit easier this way. All right, so B squared is going to stay B squared. You're not combining that with anything. 225 minus 144, they give you, what is that? A 1, and then 22 minus 14, what is that, 8? So B squared is equal to 81. You take the square root of B squared, that's going to give you B. And if you take the square root of that side, you're going to take the square root of 81. That gives you 9, because that's a perfect square. All right? So we have determined that B is equal to 9. So this is a good time to go back up here where our answer is, and we're going to put this in, and we're going to ask ourselves, does this make sense? Could this be 9? If you got an answer here that is greater than 15, you did something wrong, because 15 has to be the longest side. This has got to be the longest one. If we got an answer right there of like 18, that means you did something wrong. Okay? Could this be 9? Yeah, it looks like it could be reasonable. All right? In geometry, you don't go by what it looks like, you go by what you can prove. Well, we just proved it right there, but when you're done, you want to ask yourself, does my answer make sense? Could this be my answer? Does it look reasonable? And yeah, it looks like that could be 9. All right? Let's try one more. A squared plus B squared is equal to C squared. We're going to plug our numbers in, starting with the C value. My C value in this case is going to be 9. I'm going to plug the 6 in for A or for B. I'm just going to plug it in for A. All right, you could plug it in for B. You'd get the same thing in the very end. But to leave b squared on the left-hand side. Oops, not yet. Sorry, I need to square those numbers first. And then I can do the boxes. So 6 squared is going to give me 36. And then our c value in this case was and is 9. Whoa. So this is going to be a 9. This would give me 81. So now you're going to do your boxes here. I get 81 minus 36. Sorry, I'm running out of room right here. That's a 36. And then b squared is going to stay on the left-hand side. And I'm going to say b squared is equal to 36 minus 81. That'll give us a 5. That gives, what is that, 45? Looks good. So the square root of b squared, the square root of 45. You take the square root of both sides because the square root of b squared is b, and the square root of 45 is in between the perfect squares 36 and 49. You're a little bit closer to the 7 than you are the 6 because the square root of 45. You could put this in your calculator if you wanted to. 36 and 49, so it'd be 6 point something. And you're a little bit over halfway. I'd say it's about like 6.7, 6.8, something like that. Let's see how close we got. The square root of 45. Ooh. 6.7. 6.7. Yeah, so that's a good guess. So you'd put this right here. Now, does my answer look reasonable? If you get something longer than 9 here, you did something wrong because 9 has to be our longest side. We solved for the c value in this question, so this side has to be the longest one. We got 5.3. That's a number bigger than 2 and 5. You are to try these questions right here, and we're going to discuss it next time I see you. Keep up the hard work. Do the next right thing. I believe in you.